Hey, hi guys, good morning. Hey, hi Neetu. I checked your error. It's a missing of one jar, Neetu. So log
Yeah,
jar is missing in your project setup. Okay. So only thing is the basic funda. Whenever you get the class not found exception or the no class definition found error, it's the same. Uh, you have to search for that class name in the Google, find out the appropriate jar. Okay,
mhm.
download that jar and add it to your build path, make it runnable. That's it.
Actually, I did that because it was showing me that S4JL, some
Yep,
that kind of
SLF,
jar, right?
4J, that is a log 4J error is missing. That's it.
It did not work after that too. I think in the screenshot,
No, even for that SLF 4J, whatever is no class definition not found, see, the error message conveys that it is searching for that class and that class is not present in any of your jars. So that means either you should have that dot class file in your class path, or you should add that jar to your project, whatever that jar that contains this dot class file.
Shiva, even with we add the jar, sometimes we are getting the error. I did all
See,
those
you
things
will add
and
that jar. Let me finish this. You will add that jar. Okay. So the problem is when you are setting up a new project, generally, so what will happen is either you will be working on existing project most of the times. Okay.
Mhm.
Otherwise, if you are starting for the first time, as part of the first time setup, so you need to include all the dependency jars. So now what I'm guessing what is happening in your case, Akila. So you
I
might
got it, Shiva. I have reinstalled the Eclipse and I got it.
okay.
Oh,
Oh
maybe I have to do the same because I actually installed.
no. Actually, I think in my guess you are going wrong way. Thing is, see, unless until there is any version inconsistency, and even after downloading the jar, and if it's not getting picked up, so try restarting it instead of reinstalling fresh copy. That's fine for now. It's okay. Thing is, for your case, I saw your message in the screenshot, Neetu. So it's
Yeah.
purely that jar is missing. Log4j jar is missing. Download that, add it to your build path. Again, if there are after that, if there are any more jars missing, then it will throw same error, class not found exception or no class definition found error. If it is missing any other dot class files,
Mhm.
so then obviously you should download those dependency jars.
So
Okay.
are you suggesting, like you were telling us yesterday, I should go to the Hadoop lib file and install all the library and then
Yep.
other.
The simplest way is that what I did was for this MR test project. Okay. So go to uh, build path. So go to build path, external jars, libraries, external jars, and go to your file system. Go inside your user lib, user lib
Yeah, and Hadoop.
Hadoop. So not just the Hadoop. Okay. Here you should consider Hadoop. You should consider
Hadoop.
Hadoop MapReduce. You should consider Hadoop Yarn. Okay. And if you are using any of the APIs related to Impala, Hive, or something, going forward, not for today, but going forward, you should use them as well. Okay. So now,
Okay,
uh,
I'll do them.
inside going this, you should include all these jars. Okay. So Control A and unselect these things. and
Okay.
any of the jars that are present in these subfolders as well. So you should select all the dart jars into this, click OK, and again you should select the jars that are present in client, and you should select the jars that are present in lib. Okay,
Okay.
so what exactly is missing? The jar that you are missing is log4j. This is the one that is missing for you.
Okay.
Okay, so instead of you downloading it from Google and adding it manually, either that is one way, or you go to userlib Hadoop, and inside these Hadoop directories, wherever you find jars, include all of them.
Okay.
And Hadoop Mapreduce, in these folders also, there will be a duplication of these things, but for now, don't worry all those stuff. Okay, so don't make yourself complicated by understanding each and every point. Good to understand, but at least for the first initial go, you can skip. Okay, so include these and include the ones that are present in lib as well. In every folder, you will find userlib Hadoop MapReduce or Hadoop Yarn. You will find the jars, and inside them again you will find either client or lib folders, and even inside that those client or lib folders you will find additional jars.
Okay.
Okay.
One more thing, Shiva. So, how did you add the input folder in your Eclipse
Input folder
and output folder? Because in my case, it
output
only
folder you
shows
don't
my
need to add. Okay. See, for example, this is my word count. I think I have shown you this, but
Yeah.
input
Yes.
folder I just created under this project. Let's say if I want to create under this project, new folder and folder name. Okay, so give some folder name. Inside that I create some text file.
Okay.
I click file name, test.txt. Okay, so here you type whatever your input you want to have. Okay, so save this. Now take this path of this test file
And put it in the arguments.
Yep, exactly. Put it in the arguments.
So, Shiva, is it mandatory to put the create input folder here? Can't I just place my input file in home Cloudera folder?
Obviously, you can put that. No issues.
Oh, even that was not working. Maybe it's just my because my
You should give the full path. You might be giving the relative path, might be. You might
So
be
if I
giving the
have
relative path.
So if my input file is not inside the workspace folder, which is the path for the Eclipse, even then it should be picked up, right? If I mention in
Yes.
arguments.
Wherever it is present in your local, in your Linux file system, it should get picked up. Only thing is, you should give the complete path instead of relative path.
Okay, I'll try again. If it doesn't happen, then I'll send you
Okay.
messages again.
Okay. And today's session, as I was already alerting you, is of like more advanced. So we talked about basic concepts. Okay. So some of the advanced topics. So these are like more advanced. So this part, I mean, for today's session, except for distributed caching, I will not show you, I will not explain you the code here in the session. Okay. So my main topics for today are like input and output formats. Okay. So here I will just touch base you the theory part. How does it get split, input splits, and record reader, all those things, whatever the keywords that you were typing yesterday in the chat box. So those things I will explain here. And what are the different types of input and output formats that we can use. Okay. So till that level I will explain. Only I will share you the code examples for these. For now, don't worry about understanding each and every line inside that. Even, except my initial 2-3 years, in the last couple of years, I didn't use not more than twice or thrice this thing, only on exceptional cases. Okay, and eventually even this will get vanished. So you will find the same input and output formats or file formats being used in Hive and Pig with very minimal efforts. Okay, so I will avoid that complexity here. Okay, and apart from that, custom data types, writing custom data types. Again, this I will give you the source code examples, and I will explain you the theory part. For now, you just try to understand the theory part. Okay. Same like your custom POJOs, custom objects that we write in Java, if you are from Java background. If you are from Java background, by theory and source code, you will definitely able to understand it. It's like writing your own POJO and making it as object and using it as data type to transfer data between them. Okay. And for others, instead of, making you scaring and losing your confidence, the reason is we are not going towards these things on real-time projects these days. Almost like last 1.5 years, I rarely use this stuff. Okay. And distributed cache. So this topic is important both in Mapreduce, Hive, and many places. Yeah, this one with program coding example, I will explain you. And joins, this is again a theory. If you write in Mapreduce, and to be frank, I never written any join in Mapreduce till now. In my 4 years of experience, it's not that I'm escaping from it. If you need anyone to explain it, I can explain. But this unnecessary makes your understanding so much complex. Yeah, so that's, and we never do this inside your Mapreduce. Even if you want joins, we do those joins in Hive, Pig, or Impala, and after that, if you need any complex processing, obviously we'll go for that Mapreduce, just for parsing techniques or something, any of that stuff. But we'll definitely do the joins in Hive, Pig, or Impala. There it is just one SQL statement: table 1 join table 2. Whereas here, if you want to do that same join, at least you need to write 100 to 200 lines of code. Okay, so it's not just the presence of the features, they should be comfortable enough to use by users. Then only they will get popular. Otherwise, they will go vanish like this. Okay, so but for your understanding, these concepts, the theory part of it will remain same. So we'll be talking about two types of joins: map and reduce join, map side joins and reduce side joins. So the same keywords you'll come across again and again in Pig and Hive. So which one will be which one runs faster and which one will be slower, and why? Okay. So, and similarly, what is meant by distributed cache and how to add a file into cache. and how does that improve your performance. Okay, so these are my main agenda for today's session. So once we complete this, tomorrow we'll take up big concepts. And from here onwards, believe me, I mean, so far I might have, I might have scared you in some of the advanced topics, but starting from pig onwards, your confidence level again boosts up. Like, okay, again you will be entering into bowling power play.
Siva.
Yes, sir.
Siva, quickly, whenever you get a time today, I need like 10 minutes. I have some doubts about few things. Can we spend 10 minutes at the end?
Yep. Yeah, of course, you can call me after today's session. Every day, some people, some of the other day used to call me. You can call me after the session.
Okay, I'll call you after this. Thank you.
Yeah. Yep. Okay. Yeah, especially keeping you guys in mind. I mean, I don't go complex into these things, and as we are already not using these stuff much, but how much ever is needed, I will try to cover that. But I will give you the coding samples for them. If anyone is already good at understanding these topics, and if you want to explore the coding part of it, you can refer the coding samples, working samples, not just the copy pasted from not working samples. Okay. So, yeah. So far we have seen reading the text files in the Mapreduce, right? So how does, if you feed a text file, how does that map task is getting the, inside your map method, you specified the long writable as key and text as value, and who is dividing your file into that key value page? If you see this, someone should divide that text file, text input. You are telling it as a text input format class, and you are providing the path of input in the args of 0 you are passing here. So who is going to split your file into these many map tasks, right? As I was telling you, so the number of blocks equal to number of splits, and number of splits equal to number of map tasks. Okay, so that is the ideal situation, number of blocks equal to number of splits. Here, again, if someone asks you what is the difference between a block and a split, block and input split. Block is a physical dividing your files into physical chunks, physical parts. That is called block. Split is nothing but a logical split. So just one difference you can catch it up is that, suppose you have one very big record. Okay, so you have typed so much of data. So this entire, assume this is very big record, and this one entire big record itself is like a 130 MB. Okay. So again, you have another record which is of okay. So this is again of 130 MB. So if you talk in terms of blocks, so what is your block size? 128 MB. Okay. So these two records are there in my file. File.txt. So total you have 260 MB. Now, what will happen is, if you split this file into I mean, we don't really need to split. If you upload this into HDFS, this will get split into 3 blocks, right? So first 128 and another 128, so 256 gone, and 4 MB into third block. Whereas input split is smart enough. It always reads till the end of the record. It will not break in the middle of the record. Okay. So now, so how does it split C's? Let's assume till here it's one record, and this till here it's another record. Okay. But your block 128 MB is finishing here itself, and another block is completing here itself, finishing there. So this is block B1. This is record R1. This is record R2. This is block B2. Okay. So till here to here itself, only the block 2. Okay. So till here to it's block 2. And till here only it's block 1. Whereas your record is needing few more characteristics. Then in your block, it will be this much of size. In your input split, this will be of this much size. Okay. So that means, so your block is exactly 128 MB slices, and your input split might be more than that sometimes to accommodate till the end of the record. This is called input split. Okay, so this difference I didn't highlight you. So there are consequences. Again, the ideal the configuration here is input split size equal to block size. Okay, so then number of blocks equal to number of input splits. Some cases, okay, so some cases, if you want to consider input split size equal to 2 times of your block size, then what will happen? For every input split, there will be 2 blocks being read. So that means if you have a 500 blocks, you will have only 250 splits, 250 input splits we call them. And this blocks is related to HDFS terminology, and input splits is related to Mapreduce terminology. Okay, so you have 250 input splits, so 250 map tasks will get triggered. Okay, so this is another way that you can control the parallel processing by splitting the input split size. Okay, so there is a property that you can set for this even at cluster level or inside your Mapreduce program. So input split dot size, you can input dot split dot size, I think. Okay, so if you can set that in your conf properties, conf dot set, the configuration object you are creating, right? So input dot split dot size or something. Okay, and if you specify 128 MB or 256 MB, so that means it considers 2 blocks at a time to the input split. Then your map tasks will get reduced, the total number of map tasks that get submitted for the, they will become half of the original map tasks. And similarly, if you want to increase the parallel processing, if you make it 64 MB, that means each block will be read by 2 map tasks. since it becomes two input splits. So in both the scenarios, what is the disadvantage is that, so if we take the first scenario, if I set 2 blocks per input split, assume in this data node there is only one block available, B1, and the second block is available on the other data node, then where should it run the map task? It should run that map task either D1, let's assume this is present in data node 1. Of course, if they both are present in the same node, there is no issue. Both the blocks will be read by the map task that is running on the same data node. But if not, if B1 is present on D1 and D2 is present on B2 is present on D2, then I should run the map task on either of these data nodes, only in one of these data nodes. Now, if I run map task on this, so this block B1 is available locally to this map task, whereas block B2 is not local to this map task. I should transfer this across the network channel to here to get processed. That is the disadvantage. And one block being shared by 2 map tasks. So those 2 map tasks will be competing with each other to utilize that map block. And there is a overhead of having more map tasks. Okay, so those are the disadvantages of them. So that's the reason why the ideal configuration, the recommended configuration is number of or the size of block equal to. So this one I should put like this, approximately equal to. Okay, size of input split size. Approximately equal to means, I mean, why I put that is because of these exceptional scenarios where I had one record itself is 130 MB. Okay, so your input split size is almost equal to block size, and it will try to end at the end of record instead of breaking here. If I break here, so if I don't read the complete record, then I will not get the proper results. So by processing only till here, so I might not be able to identify what is the value, because this record will get, this split will get processed by another mapper. So that should not happen. Okay, so now we talked about blocks, we talked about input splits, right? So once the file is divided into input splits, so assume this is one of your input split. Now, who divided this into key value pairs? This is just one, you took one record. Okay, so who is telling that line offset is key? Offset is key, and the line value is value part of key value pair. So this is where your record reader will come into picture. It converts each of your record. It reads your record and converts that into key value pairs. And those key value pairs will be fed into your map task. Okay. Now, so who will be splitting? Who will be calling this input splits? Inputs, who will divide them into input splits is the input format class, that text input format that we have seen there, right? So text input format class reads your file and divides that into input splits if it is text file. If it is the generic class, the parent class for all those input formats is the input format class. Parent of all input format classes. Okay, so inside this, there will be a few methods. This is an abstract class. Excuse me. This is an abstract class. Inside this, I have only two methods. One is for get the splits. So this method will read in your file and it divides your file into splits and it gets the input splits and it returns the list of input split. And to read through this, each of these input splits, I need that record reader. For that, we'll be calling the create record reader, which returns the record reader object. Okay. Again, I mean, the non-Java guys, I mean, don't worry about the coding part of it here. So this is the more advanced topic of your Mapreduce. With today's session, I'm finishing up Mapreduce. We'll be entering into Pig. From there onwards, it's your ground. Okay, believe me. So
one question here, Shiva.
Yes, Nitu.
If we can create the input, we can specify the input splits. So in a way, by specifying some of the size, we are basically breaking the record in between, which is actually not a good practice.
See, the basic funda, the rule behind this input split is that it will never break a record into halves. See, if I specify 256 MB, do you think that if I specify here as 128 MB, do you think that this will split exactly at 128 MB? No, yeah. Obviously not. So, I mean, that's why I told you the basic initial rule is that input split will never break in the middle of a record. Okay, it will take up to 2 MB means it's not a small amount of size. Okay, where your record will go at that much level. It will be approximately to your 128 MB and it always reads till the end of the record. Got my point?
Then what is the, why are we even specifying the 128 MB size? It will never follow the rule.
Okay. Next, 128 MB is not making you sense. If I make it 256 MB, by default, it used to take 128 MB, right? Mm-hmm. And it took 130 MB. So if I make 256 MB, then instead of reading this as one input split and this as one input split, now both the records being read as one input split.
Yeah, and second one will break.
No, it will not break. It will read until the end of the record. Whatever the last record that is there, that will be read until the end of it, even if it is exceeding your property. Otherwise, you will enter into all other consequences, all other complexities. How will you process this stuff? See, this means it's not, and you are not forcing to break in the middle of record. So your wish is that I want to process 2 blocks at a time.
Mm-hmm.
Or 256 MB at a time. You should, it doesn't mean that you always exactly split that, and no matter even if I lost some of the partial records. That is not your intent. So that, keeping that in mind, framework will intelligently handles this scenario. Okay, it reads till here. It reads till the end of the record. Okay. Okay. So it reads. now do you understand the reason why we need, I mean, in case if we are going for this property, why this property is available? Because by default it splits by 130 in case if your record size is 130 MB. If you want to make it 2 records in the same input split size, then you can go for this. Or if you know this, it's exactly 130 MB each record. You can obviously specify as 260 MB also. Okay. If you don't know, whatever the size that you specify, to that size, approximately, it sets your input split size by considering till the end of the record. See, this is some exceptional case that I explained you. Ideally speaking, how will your files will be? Each to the end of this line, even if you write how much a big line. So do you think it will take more than a 1 KB or 2 KB size?
No.
Okay, then obviously it will be around that only, 256 MB dot 01 or something like that.
So in this approximation, what is the leverage percentage?
Leverage percentage, there is no percentage kind of stuff. It always reads till the end of the record. That's the rule that it follows, the framework follows.
So all we are specifying is
Okay.
V2 block
And
or
one weird worst scenario, if I have to explain you, if you have specified 64 MB as your input split size, but your entire, if your record itself is 1 GB, then obviously that entire 1 GB will be processed by one map task, and that will be treated as one input split only. But those scenarios will never happen.
Okay.
I mean, I'm getting that you're not able to digest this, taking the approximation. But if you don't take that, you will enter into another complexities. To avoid that complexities, the framework took that approximation.
Okay.
Okay.
Okay. I'll go through it again, maybe.
So what is, I mean, why you are not able to accept this?
I think I don't know. I feel that this specifying
not
this
working properly.
is not even required.
It is not even required.
Yeah, framework will itself handle everything.
Yeah, framework will handle itself. So you are not able to accept setting this property. Is it correct?
Yeah.
Okay. So it's not mandatory. See, I'm not telling you that this is mandatory. I mean, I'm not telling you that this is mandatory. Only in case if you want to change, and I told you the consequences also for this. I don't recommend also to set this. Right? If you set this, either you consider 2 blocks at a time for the input split, and I told you what is the disadvantage if sometimes if you set the 2 blocks for input split.
Yeah, the map task will be overburdened.
Yeah.
One map.
Yes. And what if you divide one block into 2 input splits? Only if you want to divide one block into 2 input splits or 2 blocks into 1 input split, then only you need this property. Otherwise, what is the need for it? Automatically, by default, it's your 128 MB. By default, it handles your number of input splits equal to number of blocks.
Yeah.
Okay. The thing is, I can completely skip these topics. The problem is, I mean, sometimes you read and you may get feel that I didn't cover these things, so I am not giving you complete. So that's why even if some of these topics are handles by framework only, have an idea. Okay.
Okay, thank you.
Yep. So Anand, what is your question?
Yeah, quickly. Where does this fit into the architecture? This input split, is it before
I'm
mapping?
coming. I will show you that diagram.
Okay, perfect.
Yep, that is there in our slide in the coming next to two slides. Okay. The split size is simply we give as block size, or is there any formula to calculate? It's simply the integral multiples of your block size. Okay. So it could be double the block size or half of the block size, or I mean, not, it may not be integral then if it's 0.5. Okay. Generally, if you want to increase the number of map tasks, maybe in very rare scenarios, you can reduce that input split size to half of your block size, or you can double if you want to reduce the number of map tasks. Okay, only those two scenarios you will try, even in exceptional cases. Okay. And yeah, so inside your input parent class, so you will have two methods, one to get the splits and other one to create the record reader. So splits are, so let's, I mean, if we go a bit about splits, splits are a set of logically arranged records, a set of lines in a file, or a set of rows in a database table. Each instance of a mapper will process a single split. That means there will be one dedicated separate map task for single input split. Splits are implemented by extending the input split class that we will see there. Okay. And Mapreduce framework provides many options for input split implementation. So those are Hadoop files, input split, or HBase. Okay. So these stuff, we don't need to worry about it at all. Okay. Next, yeah, if you see this, if I have, this is my data to process. Okay. So this is my data to process. The first step that happens is your, if you call this text input format, that will call the get splits method, and your file got divided into splits. And the second method inside that input format, we have seen record reader. So each input split, now your file got divided into splits, and each split being read by your record reader. Okay. And this record reader converts them into key value pairs. Reads, and record reader reads your each of line and converts them into key value pair. And those key value pairs will be sent to your map task of your mapper class. This is the pre-steps involved before your map task. So this much of low-level details we didn't see till now. Okay. So where we need to write this logic in mapper class. You don't need to write this logic in anywhere. So by default, the framework handles for you. Okay. So just by specifying inside your mapper class, inside your driver class, just to specifying it as text input format, job.set input format class of text input format dot class. This is the line of code that does all these functionalities in the backend for you. Okay. Okay. So now coming to that text input format. So what else? What others are supported? So here, this list is only a few. Okay. So there are other file formats also coming. I will cover those file formats and all its compression techniques, all the other stuff in Hive and big sessions. Okay. For now, we'll take only a subset here, and I will just explain you here. But in Hive and Pig, you will see coding examples, and it's just one line of specification. That's it. We'll see them there. So here, job.set input format class, whatever the input format class that you want to specify, that you will specify. So if you are reading a text files, it's always text input format. And the same text files, instead of going by the block size, if you want to split your, if you want to calculate the number of splits by the number of lines, let's say I want every 1,000 lines to be processed as a one separate split, or every 1,000 lines to be processed by one separate map task. Then then I can go for n-line input format. And DB input format is when you are going to interact with any RDBMS, Oracle, MySQL, Postgres, all this stuff. Okay. Anyway, these days DB input format is no longer directly being used in Mapreduce, because there is one tool called Scoop, which submits the Mapreduce jobs using this DB input format and reads in your data and puts that into HDFS. So this is to read in from RDBMSs. Yeah, since we have that Scoop tool got evolved, and which does the same stuff. It writes Mapreduce programs using this DB input format only to copy or to read your Oracle, MySQL, Postgres, or MS SQL Server, or any of your RDBMS. Okay. And this table input format is to read in your HBase tables. And this stuff, anyway, we will see this example while our HBase sessions. Okay, where we will be discussing our HBase sessions. And HCAT input format is to read your Hive tables through Mapreduce. Okay, again, this we'll discuss during the Hive sessions. Okay, so even if I forget, just remember me, remind me. I will explain you that as well. And sequence file input format, this comes to other than text. So there is a binary file format which is supported in HDFS, and this was very, very, very popular 2 to 3 years back. It was widely being used 2 to 3 years back. But these days, no one uses even this binary input format, because there are many better file formats that are available. Okay. And the comparison chart between those file formats and those compression techniques, I will take one complete session during our Hive sessions, Hive classes. It almost needs like 1 hour to 1.5 hours. So each file format and their compression techniques and which one is better. Okay. So then obviously we'll practice. We'll not worry about all the obsoleted file formats, even though you will see sometimes in the Google search result. The same way like applets in your Java. So they were utilized, they were used a lot in the initial days, but slowly they got deprecated, right? So no need to learn now when you are learning your Java. So similarly here, so some of the deprecated file formats, and it's not deprecated in the sense they're not utilized, they're not using, no one is using, because you will understand the benefits of other file formats. Okay. So for now, let me stop with this, just the list here, with this list. So text input format, you see here, the input split is equal to single HDFS block, and this can be configured, the property that I have shown you there. And record is line feed or carriage return, \n or \r is used to denote the record delimiter. And key is always long writable, position in the file, which is the line offset in the file, and value is the line of text. And n-line input format, instead of going by the block size, you specify how many lines you want to process. 1,000 lines, 10,000 lines, 1 million lines by one map task. Yes, you can do that. So n-line input format, here what you will change is, instead of text input format, you will change this as n-line, and you specify how many lines per the split with this line, n-line input format dot set num lines per split. So 100 lines, 1,000, 10,000, it's up to you. Again, record is a single line of text, and line offset is the key, and value is the line of text. Okay. So table input format will cover this in HBase. Okay. And similarly, the way you have seen the pre-steps before map task, and we have the output formats also, which comes into picture after your reduced task. Okay. So in which format you want to write your output? So by default is a text output format, and inside this text output format, if you see your content will be key and values fashion, and key and values will be supported by, separated by \t tab. They are tab separated. Okay, in your output file. And here we don't have the concept of input splits, record reader. We don't have that. We have record writer, so that we'll see. No need of splits here because you are writing them into files. Okay. Obviously, each reduced task will write its own part or file. That itself is a file. Okay, so no need of splits there. And to specify the output format, we have this method available, job.set output format class. It will be text output format if you want to write directly to RDBMS. Anyway, this is not being used much now. So table output format if you want to write to HBase, and if you don't want to write anything, you can specify null output format also. Okay. And if you want to write one of the binary file format, sequence file, and all other binary file formats, I didn't even name it here, but I will show you in Hive sessions. Okay. At least for the name's sake, if you want to know them. So sequence files, we'll be seeing them, and RC files, record columnar, ORC, and park, even the Abdo files. Okay, but these days, all these three gone. So these got evolved in the same order. First, sequence files came into existence, and then Abdo files, and then RC files, and then ORC, then actually park and ORC almost came parallelly around the same time, and This ORC is the latest one. And we'll be most of our practical examples also, even in our projects, other than these two, we don't use any of these things. Okay. So why these many evolved, and what are the drawback? That level you really don't need it. Okay. But I will tell you the advantages and disadvantages. That's it. And with respect to performance and storage capacity, all this stuff, and what are the compression techniques that are needed. So if you are creating a file, means obviously you will go for sometimes when you are especially dealing with huge size files, you will be interested in compressing the files as well. Those compression techniques also we'll discuss there. Okay, let me park this topic until then. Okay, so this is a text output format. So saves key value pairs. So, and you can specify the separator. By default, it's a tab separator, right? If you want to override that tab separator by comma or something, you can provide your value via this. And set output path and path. This we have already seen here. Okay. Table output format to write into H table. Okay. So now you see this flow. Here you should understand all the steps in your Mapreduce job. I have an input data. Okay. So I want everyone to pay a very close attention here. I mean, careful attention. So to understand the sequence of these steps, I have an input data. Okay. So this is one block, and this is another block present in node 1 and node 2. So this is being read by your input format. This is read by your input format class. What does this input format class does later? So some data, it's not just one block. Let's assume some data is present in this and some data is present. Okay. So now, assuming it is having 3 blocks, it got split into 3 splits. And for each split, we have a separate record reader. And after each record reader, each split gets processed by a separate map task. So I have 3 map tasks. And after map tasks are completed, there is one combiner which combines all your map outputs and sends them to the partitioner. And partitioner, assuming 2 reduce tasks will be running, so this partitioner will produce 2 files and this partitioner will produce 2 files. Okay, so these 2 files will be sent to shuffle and sort phase, and here again 2 files will be sent to shuffle and sort phase again. Okay, now shuffles, this part 0 files will come here and part 1 files will go here. And then sorting of your values by keys will happen. Sorting of your records by keys will happen in this sort phase. And that sorted records will be fed to your reduce. And your reducer, once it writes to context object, then your output format class will come into picture. And this will write into your final output directory in whichever format that you specify. If it is text, it's text output format. If it is sequence, if it is binary, it will write into binary output format. Okay, so let me recap once again. Let me explain you this flow once again, one step after just quickly. So this is input data, first picked up by input format and then gets split into input splits. Then each input split will be processed by record reader. and the record reader output will be processed by map, and map, if there is combiner, if you enable combiner will be there, otherwise directly to partitioner. Okay, so assuming combiner is there, combiner will run, and then partitioner, and after that shuffle will takes place, and after shuffle sort will takes place. In shuffling, part 0 files will come to one side and part 1 files will go to another side, and across all these part 0 files you will sort the keys. Okay, so once the keys are sorted, you will process them in the reduce, and reducer will send output to output format, and output format will write into a directory. Is it clear? Anand? So this is what you are expecting, the flow.
Yeah, absolutely got that right. Exactly. Perfect.
Okay. Yeah. So yeah. Let me move on to next. So that's it. Input and output formats. And the data types, the key value pairs, data types.
Siva, one quick question before we go into data type.
Yes.
When we derive the intelligence out of this, can you go back to the slide, please? 1 second.
Okay.
So when we derive our metrics, but we derived metrics yesterday from combiner, right? Not prior to combiner. We wrote some Java code, right, to get those top 500 or top salary, right?
Yep.
Where does that fit into?
This map method and reducer method. See here, only in map task and reducer task we write our logic, and all other stuff will be handled by your framework. So many boxes by framework, only 2 by us.
But prior to writing to database itself, we will derive our metrics.
Metrics in the sense you're talking about number of mappers, number of reducers, that stuff.
No. I'm talking about, like, top salaries.
Top salary. Top salary you will decide in the reduce phase before writing into your file.
See, this is where I'm confused. This is exactly the point of confusion, because in ETL, we write to database, and that to database we write the queries to get the intelligence out of it, right? To get the metrics, all those. And here it is a little.
So this is your, assume this is your database. Okay.
Correct.
You are reading through map. Okay. You will pick up here. You do the selection. What are the fields that you are interested in?
Right.
Okay. So here you do the aggregation. This reads into the records, but here you will select only the columns that you are interested in, and here you do the aggregation stuff.
And then you write the aggregation back to database?
Yes, obviously. Back to, I mean, you should store the result, right? Somewhere.
No, because the results will be on the dashboard, right? The results will be on the, for the user.
Yeah, because that is for end user. Okay. So here also for end user only. If you are writing into a file, he can refer to that anytime. Otherwise, again, if you want to show it into here, we don't have that dashboard integration directly with Mapreduce framework. You should write them into a table, the results, and then you provide some graphical user interface by connecting through some devices like your MSTR or something like that.
Oh, okay.
Okay. First, you should store your results, Then you connect any other tools and show them in the dashboards.
Shiva, one quick question here. This is
Yeah,
Lakshman. See, the output format can be anything. Could be Avro, Parquet, or whatever format you mentioned earlier, right?
Yep, I mentioned
card.
Yep.
Yeah, okay, card. Yep. Thanks.
Okay, but I didn't explain you much details on these things.
I got it. Yeah, thanks.
Oh. Is it clear, Anand?
Yes, Siva, I think so. So then when will we'll talk about that when we get to high.
That obviously we have almost like 10 hours or 8 to 10 hours allocated for that.
Okay, no problem.
Okay.
Thank you.
Yeah. So now, so far we were seeing the key and value data types as long writable, text, all this stuff. But we didn't discuss much about what is writable. So in computer terminologies or computer technologies, if you want to send data from one machine to another machine through network channels, okay, so if you want to send data from one machine to another machine, one node to another node through network channels, that data should be in binary format. Okay. The data should be in binary format. So converting your object data. So let's say if you have an employee, and inside this employee you have some attributes, name, ID. So if you write a class, these two will become variables inside the class, and this will become an object, right? So this converting this object data or converting any data into binary format is called serialization. This is called serialization. Okay. And why do we need serialization? This is not just introduced in Java or not just introduced in Hadoop. Okay. So this is there from computer networks concepts itself. If you have to transfer some data from one machine to another machine, that should be through the network channels. The data should be in binary format. Okay. And converting that into binary format is serialization, and converting that again so and so particular format to, so here the binary formats, all these are like binary formats only. And even prior to this, all these binary formats, we have a way to store them using the writables. Okay. So writables classes, if you use any of these methods, so it stores the data also in the HDFS into the binary format. While you are submitting the cat command, you will see that again binary format back to your readable format. That doesn't mean that it is storing you. So when you apply a cat command on your HDFS file, it displays the contents in readable format. That doesn't mean that it is showing the data as it is in the background. Okay, so it uses some, even in text and text input and text output formats, they are not binary files, but it does some kind of serialization too. Using these writables inside the text file, some of the values will be serialized. Okay, so don't go till that level. It's a never ending, like it's a keep on digging. Okay, so these are binary file formats, and before the file format itself came into existence in binary, so until then we were using the binary, the data types to serialize any of your fields. If I want to, if I have a field, name as a field, if you have it as a string, instead of storing this as a string, you will serialize this field, convert this field to binary. To convert a field inside the file, and instead of converting the entire file itself, just to convert that a field there, you name it as a writable. So what will be there inside the writable methods? So writable is an interface, and writable comparable is another interface. And basic theoretical funda here is, so writable interface will have read and write methods. Read fields and write. So this is one method and this is another method. Since this is an interface, you will have only the method definitions. And inside this, writable comparable extends writable interface. Okay, and comparable, or if you know inside Java we have comparable interface. Comparable interface. Inside that you will have only one method. Int, it returns integer value, compare to. Okay. So by extending this writable and comparable both, so this another interface become writable comparable. This is named as writable comparable. So inside this, you will have three methods, all the three methods, because we are extending them. So read fields, write, and compare. So the reason why we need writable comparable, though we have writable, this writable is only for reading means deserialization. So converting your binary format into your readable format. And writing means taking object format to this we call as a serialization. Okay. So why do we need comparable? In order to compare two such writable fields, you declared some int writable or long writable. So int writable is there. Int writable of 50 is there. And another int writable of 100 is there. So in order to check which one is greater than, you have to compare them. And if there is any object that you are comparing, that should implement the comparable interface. That is the requirement, prerequisite from Java. So that's why we extend the comparable interface also with three methods. It becomes writable comparable. Now, in our framework, in our Mapreduce framework, if you want to compare the values anywhere, you need your value data types also to be your writable comparable. Otherwise, value type can be writable type. Coming to writable comparable, it's, as I told you, it's an interface used for comparison. I mean, whichever classes that implement this interface, those objects can be comparable. So in our framework, there is a phase called shuffle and sort. And in that sort phase, only the keys will be compared and keys will be sorted, not the values. Okay. So in that sort phase, your keys need to be compared in order to sort them. So for that reason, you should mandatorily have your key data type to be implementing your writable comparable interface. Okay, this is again all the background stuff. Now, if you want to And by default, the default data types that we have, so int writable and long writable, double writable, null writable, bytes writable, and float writable. So all these are the implementations, all these are the classes. Okay, here writable is an interface and writable comparable is another interface, whereas these are their implementations. Okay, so these are the classes that they provide the implementation for these two methods, for these two interfaces. They directly implement this writable comparable, which in turn means that they implemented writable and as well as comparable interface. So that's why, since you are using these stuff, these objects, these classes as data types, so they get compared with each other in the short phase, and that's why you are able to compare those values in reduce method. This is the backend stuff that involved in the data types. Now, suppose if you want to if you want to compare, let me take one simple example here. So I have 4 fields, I have 4 fields. Okay. IP address, host name, and the IP address, host name, number of visits, number of page visits, page views. Okay, this is my log file format, let's assume. Okay. Inside this, if I want this to be key and this entire thing to be value, okay, so host name is a string, number of page views is a integer. If you convert this into string and if you separate them by comma, entire value as one string, so storing them as one string is one way of processing. Or if you think in terms of Java POJOs, this is like one object and this is like another object. Here there is only one field. You can declare this as a text because IP address includes dots also there, right? 192.168. So because of that, we declare that as a text. So if I want to use this emit as a value, okay. So one simple approach is combine them into string host name plus so number of page views. Okay. Yeah, this is one way. You take these 2 fields into one field, concatenated field by some delimiter, and specify that data type as text. Okay. So there is one more complex way that you can do. You can write custom data type. You type them, you name it as custom writable implements. Okay, so implements writable comparable of the same type, and you provide the implementations for, you declare those 2 methods, those 2 fields here. Okay. Int writable, you take this host name as a text, private text host name because host name is of text type, and private int writable page view count. Okay, and you provide these 2 methods and getter and setter methods for them, and you will provide the implementation for read fields method and the write method and compare to method as well. Okay. So this is to the extent, I mean, if you want to go for a complex data type and your custom data type, if you want to write your own writable type, okay, so then this is the process. For this coding example, I have given you a link. This is present in our blog, so you can explore more about this data types and how to write a custom data type. How did I provide the logic inside this? This is again reading one field by field inside the read fields and write and compare. Okay, so I leave that based on your interest and your confidence on that. Okay, but these days we don't go this level. Earlier, even if you want to combine these two, you can just put them some tab separated or key comma separated these two fields and concatenate them and take this as just one field and send them to through the mapper output. And again in reducer, break that field by that delimiter and get that into number of splits, number of fields. Okay, so that is the simplest way. This is some complex way that you can achieve that as well. Okay, so I think I have a question from someone. So this custom data type will be used in mapper. Yes, you can use this in mapper. Okay, maybe I can give you this as assignment for you, Murli, because you are 5-6 years experienced into Java, right? You can easily understand this and you can practice this. And for others, and I don't recommend this because I don't need to explain this read, write methods and posos to you. Okay. Yeah. So that's about the custom data types. So to implement the custom writable, so we write the write and read fields and compare. These are the methods that we need to provide the logic. And sample writable with author and content, two fields being treated as one object. Okay. So next, so those two topics, just understand just familiar with those keywords and you should not get surprised when someone talking about those keywords. You should know the theory at least. Next, coming to the distributed cache. Let's say I have an example. Okay, I will explain you this with an example. I have one very huge file, let's say 10 GB file. Okay, let me take the basic example, word count example. I have to count all the words except starting with some characters. Okay, so I don't want to count the words that start with ABC. I don't want to count words that start with ABC. I don't want to start words that start with A here. Okay. So there is a big list. There are 1,000 character strings that I should exclude them. Okay. So this exclude now. So I need to count the words from this file, but I should exclude all those words that start with these key patterns. This is the input file. exclude.list. This is another file. Okay. And so far, we have seen reading only one file into Mapreduce. Here, we were specifying one file in the sense you can even feed the directory, but that should be in the same format, right? So you can directly feed the directory. Even if you have 100 files inside that, all 100 files will get read, but they all will be in the same format or the same schema. So now if you want to read another second file which is of different type, okay. Now you should read this input file through here job.setInputFormat.set text input format class, and you will specify the path of it by using the add input path of this. So if I have to read the second file in some other directory, I should read that file through HDFS once again, right? So here they came up with a solution like so in order to read two HDFS files and to explain you the performance phenomena also, again if I take HDFS and LFS and cache. So cache means RAM memory, right? So anything reading from RAM will be relatively faster than reading from here. This will be fastest. It will be faster than your LFS. So reading from HDFS will be relatively slower when compared to reading from local files. And similarly, reading from RAM will be even more faster than reading from LFS. This is the performance phenomenon. Now, assume if you have one big master file in HDFS, that is 10 GB file in HDFS. Okay, so for every block reading, I should make a request to HDFS, and inside that, for every record, I should read it from HDFS. Okay. Now, I have this just a 10 MB file, which second file, which contains this exclude list keywords, because this is just a few keywords, 1,000 or something, or even if it is 10,000, if it is just one string, it will not be more than 10 MB. Okay, so 10,000 or 1 lakh or even 1 million. Okay, so I have this 10 MB file. So if I have even this 10 MB file also on HDFS, for every record, so whenever I read a word, okay, so here from 10 GB file, I received a one record, so like this. And while processing this record inside my map method, in order to check whether any of these words, let's say I split this file, I split this record into words, and I received this one word, and I should check across all these strings, all these keywords. That means I should have entire this file available in my map method to check whether that is present in this or not just 1 or 2 records. So that means either I should read this file, entire file for every record, because once you come out of this map method, again that record will be lost. And when you are reading the second input record, you again need to read the 10 MB file. So that is one way. The other way is I was telling you before the map method, there will be a setup method and map method is available. This is map method. This gets called once per every input record. Okay, and this is only once per map task. Now, so this 10 MB file needs to be processed only once, need to be read only once, and I have to store that data somewhere available. Correct, right? So here, if I have both these files in HDFS, I should make calls to, I should make both the HDFS IO calls to for these two files, for both these files, right? Instead of making HDFS calls to both of these files, since this file is small enough, and I can store directly into my cache memory. Inside cache, I will store this 10 MB file here. Now reading this file will be very faster, and it reads it once and stores that in a collection, and that means in memory, and that you will refer inside your map method. This is called, you are distributing this file, 10 MB file, into the cache memory of each of your data node. So now this file, 10 MB file, will get copied into RAM memory of each of your data nodes. Because this setup method will get called only once by each of your map tasks in each of the data node. So if you want to read that file locally, so that file will be available locally to each of those data nodes, but not on the HDFS. Of course, if it is there in HDFS, all the data nodes can read, but to improve the performance, you're loading since this is a small file, it can fit into RAM. So even for reading that small file, you don't need to make, for every record, you don't need to make an IO call to HDFS. So one way, by moving this into RAM, you increase the speed. And another way, by reading that small file in the setup method only once, instead of reading that multiple times by placing that logic in map method, you increase the performance once again. This is one way you increase the performance, by reading it only once and storing that in a collection. And the other way is you moving that file into the cache memory of each of the data nodes. And that cache memory we call as a distributed cache, or this technique we call as a distributed caching technique.
So why do we need it on each data node? Why can't we just have on the master?
Okay.
Because data. Yeah, go ahead.
Okay. So master means, again, the data nodes will have to go there and fetch it, right?
Yeah.
So that means the network data copying is needed. You have to read it through network. See, always it is easier to pick up something that is present in your home than going to other street and walking through the street and getting from other shop. If it is available inside your home, it's easy to use it. Since this is a small file, you can copy this. So this one, you can choose up to 500 MB. If your second file is small enough, up to 500 MB, you can choose this into distributed caching. Or if your servers are old, then you can limit to 100 MB up to. So if you put it on master, only in master, again all the data nodes, it's as good as keeping it in HDFS. HDFS is a layer, right? Reading from that is as good as, but the problem, you're trying to increase the speed by loading that into RAM memory.
I see. This will help for the retrieval of the record, not for the storage.
Not for the storage. This is not for storage purpose. This is for processing, optimization technique. This is one of the performance improvement technique.
For the retrieval of the records, right?
Yeah.
For the query.
Yes, for the retrieval of the query. Yeah.
I was thinking more from a storage point of view. What does it help? It doesn't help. Okay. So
storage point of view, it doesn't help.
Okay. Perfect. Thank you.
And obviously, this 10 MB file with whatever is present in HDFS, while processing, it gets copied onto distributed cache. And once after the job is completed, the 10 MB file from the RAM memory will be will be flushed out, leaving that free space. Okay. So that is the basic funda that involves in the distributed cache. Now, so this is again another old API that we do. Let me show you the latest code in the Eclipse itself. So if you have one HDFS file and another HDFS file, that small file will get copied into local copy, gets copied into the RAM memory of the data nodes and available for map or reduce task. Okay. And it's not just the files you can add to RAM memory. You can also add the jars. You can also add some zip files using. You can add a file to distributed cache by specifying -files in the yarn jar command. So we were using yarn jar command, right, to submit the Mapreduce job. There itself, you can provide a file name -files and followed by the file path. Okay. And if you want to add any jar to the RAM memory in order to increase the speed, you can use -libjars, and you can add, you can specify -archives if you want to add any .zip files this way. Okay. So now, once you add that file, it will get copied into RAM memory. In order to read that file, we'll read that in the setup method. Okay. So setup method, we read that file same like your any LFS file. Okay. So whatever the file that present in RAM, so that can be read similar to your LFS file using the Java file reading techniques. Okay. So here, this is one way that you can add through the driver program. But again, this method, I don't recommend, because if there is a path change to your file, you have to go inside your code and change and rebuild the jar. Okay. So there is a simplest way that I will show you in our Eclipse program itself. Yeah. This is my mapper. That is my driver. This is my mapper. and somewhere it would be the reducer port count. Okay. So inside my driver program, so I took the configuration. Okay. Again, this configuration set conf and get conf, return conf. All these are not needed. Okay. So might be DVAT. So we don't need that. Okay. Just same as your typical regular conf creation, you can create that configuration conf equal to new configuration. That's enough. Okay. That creates the object. And job object we created, mapper class. We are setting the word count mapper with the distributed cache dot class. Now, I'm not adding any file to distributed cache here. This looks pretty same as your typical driver program, right? So any change you observe, forget about the above methods. Those are not needed. Okay. So by maybe for some other examples, I might have written that, but you can replace even this line change with configuration conf equal to new configuration, and all other lines remain same. Mapper class set, you have set the mapper class, you have set the reducer class, set the output, input, that's it, ran it. Okay. Now coming to the mapper. Even here, so I'm assuming the file name to be exclude file.txt. I mean, I'm taking that file, which file to read from the distributed cache. That file name should be available here. So I set this file name here. Okay. Now, so I have created a one set. Set means the unique values, no duplicates, right? Inside my setup method. So till now we didn't see any line being written into setup method, right? We were seeing only the map method. Now inside my setup method, I will be reading this exclude file.txt. Where is this file? Assuming this file is available in distributed cache. I just specify the file name here, and I'm reading it as a regular Java file. So in Java, how can we read files? As I told you in Java sessions, like file reader. So this is the file path, new file of file name, and using the file reader and made it buffer, converted into buffer reader, and reading the line by line. So I get the buffer reader dot read line. I will get every line. So every line contains the exclude list, one exclude list that I'm adding them to the set. And finally, after reading this entire file, and I prepared this exclude set with all the keywords, and I closed this file in the finally block, and this exclude set will be directly available inside your map method. I don't need to call the map method anywhere. Okay, so that will be get called inside your mapper itself. Inside your run method itself, you don't need to explicitly say. Whatever the set, exclude set that you created outside here, outside of your setup method, and I populated that will be available inside your map method. Now, whenever I receive a new word, see inside my map method, it's the same process. I took each line and split that by space, and for every word, and I'm checking the first character, and the first character, I might be excluding only based on the first character instead of multiple characters. Okay, exclude set. If not, exclude set contains the first character. That means this first character is not present in the exclude set, then only write it. If it is present in exclude set, then I don't need to write that. I should exclude that. Okay. And also I'm printing the counters as well here, but let's not worry about the counters here. Okay. Now, so one constraint with the distributed cache here is that you can't run them in locally in your Eclipse. You can only run them in HDFS mode, MapReduce mode. Export it. Now my file name is exclude_file.txt. Okay. Let me see if I have anywhere in this. So when I call this method, so yarn jar name, the job, this should be there. Let me look for Control-R. Sorry. Yep. Okay. So this is a long time executed. The command mr_ dist _ catchy.jar, and inside that my main method is this one, and -files. This is the file that I want to add it to distributed cache, and this is the input. So before executing it, just let's verify the input and output. Just the input file. Okay. Let's see the contents of your input file. For the files that are present in HDFS, and if you want to add them into distributed cache, then you should provide the full URL, including the HDFS : // Even for your input and output files, you can provide them, but they are optional. For this file and this file, they are optional. But for this, anything that you want to add it to distributed cache using the -files, that is mandatory. Okay. So I have this wc input.txt. I only have the 9 words inside this. I want to print only the exclude file text. I want to print only those words that doesn't start with the below characters that are present in exclude list. Let me see. So what am I excluding here? Okay, so I want to exclude all the words that start with A, and that start with B, and that start with C, and that start with D. So that means I should not get Bill, and I should not get Don. So reading these two files. Even in coding, the only difference that we have seen is we read that file locally inside your setup method as like a local file using the file reader. If it is from HDFS, then I should have used the HDFS Java Client API. So that we have discussed during our HDFS session. So this file reader and buffer reader means this is directly reading Java file from local file system, or similar to local file system. And this is the file name that it looks inside the RAM, the cache, distributed cache layer. Right. Okay, so job got submitted. At least for interview purpose, so have an idea on how does this work. Okay. So because even though they don't use all this stuff in real-time projects, but I know what will be the questions for interviews. They will ask you that if you don't know this, you can't do anything kind of stuff. They will be under impression. Because some of the guys will be from Java background, so they will try to show off their programming skills. Yeah.
Eva, how did we verify that
got
the cache
added
file
to RAM memory?
Yes.
Yeah, I thought when you were asking how will you verify, I thought that what will be your question? Nice question. Yeah, I mean, even I got the same question, but yeah, there might be a way, but I'm not sure.
That's fine, no problem.
Okay. Yeah. So the basic funda, I mean, you can confirm that is, so here inside your setup method, you are reading through Java API, not through HDFS API. HDFS API, we were using FS data input stream, not the file reader, not the buffered reader. We were using the FS data input stream to read a HDFS file. Now here, I'm reading just as a local file through the Java. So if this program is successful, means that read your file locally from somewhere. Okay. So if it has read from HDFS, obviously it will throw an error message because your Java file reader or buffer reader can't directly read the HDFS file. That is the basic confirmation at least you can give. Okay. So since this is my VM, obviously you'll not see the performance improvement in these machines because running the Mapreduce job itself will take, the basic Mapreduce job itself will take time. But in real time, you will see this improvement. Okay. So if this job gets completed, okay, at least till then, if you have any questions on theoretical concepts that we discussed, we can discuss them before I move on to joins. No more questions? Okay. Yeah. So then let me take the joins by the time it gets completed. Okay. Finally, it got completed. So Hadoop fs-cat mr_out to class. Right? This is the relative path. That means it's present in my home directory. So I got only Jack, Jill, Joey. All the ABCD, whatever the words that start with letters ABCD are excluded. Okay, so take this code example and make a jar and execute it, and just practicing that itself is assignment. Okay, so I don't want you to write any more programs on that. Understand that thoroughly from programming perspective. Okay, now, so since you have the one file, a smaller file, and you read that inside your map task and you process that. If you have, instead of referring that, if you have to join them by any column, okay. So if you want to combine them by any column, so there are two ways, because mainly our processing happens in two phases. One is in mapper phase, and second one is in reducer phase, right? So you can perform, if you have two tables or two files, this is a table X and this is table Y. So if I want to perform a join in reduce side, so in a reducer phase, okay, I have to read this file. Let's say I have 100 columns in this, and I have 20 columns in this. Okay, and after joining, I will be producing my result. So here the two types of joins that you can perform. So one in map side itself, and second one is in reduce side. So if I have to perform the join in reduce side, I should read in this file through mapper phase and combiner, partitioner, shuffle, sort, and reducer. And this file also same that way. Now, after coming into reducer, you joined them, and here 100 columns are there, here 20 columns are there. And in your final result, you got only, here let's assume here 1 million records, here only 1000 records. So after joining, you got only 1000 records as output. Just to get the 1000 records output, you have to transfer your 1 million file through all these files, all these stages. So that is why your reduce side joins will be relatively very slow when compared to performing the joins inside your mapper phase. Instead of doing that join in reduce side, if you could have done that join here itself, so table X and table Y joined inside your mapper only, this 1 million records versus 1000 records, and you got that 1000 records result here itself. Now you will be moving only 1000 records to the combiner phase, to the partitioner phase, and to the shuffle and sort phase, and finally to the reducer. So you reduce a lot of data transfer. Obviously, your execution time will be reduced and your performance gets increased. So that's the reason your map side joins perform faster. And here, the limitation is you can perform the join inside Mapreduce, inside a map phase, only when at least one of these tables is small enough to put into distributed caching. Because while reading this record, this is 1 million file, while reading this block by block, in order to join with all the records inside this file should be available in each of the map tasks. If this entire file is not available, then it can't check whether its corresponding record is present in this or not. Right? For that reason, this file should be small enough to fit into distributed cache. That means if you have one table, one small table and one bigger table, then you can always go for a map side join. One small table and one bigger table. If both are small, obviously you can do in map side join. If both are big, that means one table can't be fit into distributed cache. That means the table is greater than 500 MB or so, then you might not be able to use the enjoy the fruitness of the map side join. Okay. These are the two types of joins that you can perform, and the disadvantages of. We have seen the pros and cons of both the joins. For map side join, the performance will be better, but there is a limitation that you can only perform this with, at least there should be one small table among the two tables. Okay. Otherwise, if both are big, then obviously you have to go for reduced side join, and the reduced side join, as usual, will take relatively longer time. Okay. So that's the 2 points that I wanted to bring to your notice about the joins. So now you should note down that map side joins perform faster than reduced side joins. This is the statement that I want to feed into your brains for now. And miscellaneous concepts we already talked about, I think. A record reader, shuffle, sort, and all these things. And there is. So till now we have seen all our Mapreduce programs written in Java. Okay. So you can write your Mapreduce programs using C, C#, Perl, Python, Ruby, even in the Linux shell script also. You can write your map logic and you can write your reduce logic in those languages as well. To support the multi-language feature from Mapreduce, this Hadoop streaming got evolved. Okay, so this relatively runs slower than your Java native API. Obviously, this Hadoop streaming runs relatively slower than your Mapreduce Java API. Okay, so if you need anything advanced on this topic, you can refer our blog, hadooptutorial.info, the Mapreduce streaming or Hadoop streaming, you will find there. Okay, so some examples with at least shell scripting. Okay, C and C++, I think I didn't write any articles. I have some examples. If anyone got some real-time requirement, then you can reach out to me if you want to write anything other than Java. Okay, but I am not covering that here. So that is called as Hadoop streaming. So writing your Mapreduce programs other than Java language is called as Hadoop streaming. Okay, and for any further references on Mapreduce, so check back to these docs, Hadoop documentation, or our blog also. You'll find some of the useful articles. Okay. At least by the completion of your preparation for your interviews, so I would recommend you to be completely comfortable with all the topics. So I have documented some other advanced topics also here. Okay. You can find all of them. A few more in detail or advanced topics. Okay. So inside this Hadoop, so now you can refer to all these topics. Like inside Hadoop, you can refer to all these topics. It includes both the admin. I don't segregate in that. In writing articles, I don't segregate them for developers, for admins kind of stuff. I try to write in and out of that topic. Okay. So all types of installations, design concepts, commands. I think this I have already shown you. HDF Hadoop part. And coming to the Mapreduce side, sample Mapreduce programs, Mapreduce data types. So how to write custom writable data type, basic components in MR program, and combiner, Mapreduce job, yarn job anatomy, and what are the predefined mappers and reducers available, what are the different types of input-output formats, and there is one different exceptional scenario, so multiple outputs use case. I think this one I didn't cover in the output format, but you can refer that. And output formats, MR unit, Hadoop streaming, and what are the various ways to performance tuning of your Mapreduce jobs. Okay, so I can refer to that performance tuning of the Mapreduce jobs and some of the use cases, some complex algorithms, and performance testing, performance tuning. Okay, Hadoop performance tuning. What are the various ways? So this one, I will try to revisit this page, the same article, and I will show you this once I complete the file formats and basic stuff. Before that, I want you to be ready with all the topics that we discussed. Okay, we can talk this topic anytime later. I can spend 5 to 10 minutes and explain what are the best practices for performance tuning and all. Okay, so with this, I'm wrapping up the Mapreduce sessions. So anything left out or any common topics? Because the file formats, compression techniques, performance tuning, these are like common topics for all the processing tools like Mapreduce, Pig, Hive, Impala. So in every place you need those common topics. Okay, so there I will cover, because it makes your understanding easy and it reduces your complexity.
Siva, one quick question.
Okay.
So when we write the metrics to the database,
Yeah.
do you have ad hoc capabilities? Like
Add up means what?
Meaning, ad hoc meaning, like, where I can create the metrics over the fly instead of storing it on the database.
Oh, okay. No, you have to store them either in a file or in a table. On the fly, so if you have a table, if you already have some structured data, then you can do. If you already have some data in a columns format and you have that table created inside that, and on that table, if you want to calculate the metrics, then on the fly you can connect through some of the reporting tool or visualization tool like Tableau or ClickView or Splunk or MicroStrategy. Any of those tools, you can directly connect it to your Hive tables. Then you can, on the fly, you can prepare some metrics.
Okay.
If it is a file, obviously you have to convert, you have to process that and create a table on top of that with that structured. First, you have to make it structured in order to deal with your reporting tools. Right?
Okay.
Yep.
Okay. And last one. So if there is unstructured data, then how do we make those joins?
So unstructured data, so you parse that comma separated or tab separated or delimit any other separator. You make them into fields, and by some field, you write them into files, and then you perform the joins.
Okay.
Okay.
Yep, perfect. I'll call you shortly, man. In 10 minutes?
Okay. Yep. Or in another 2 minutes, if once after I ending the meeting, you can call me. No issue. Okay. So hi Siva, how can non-Java people get break in this field? Generally postings asks for 5 years of Java experience. 5 years of Java experience, if they ask, at least you need to spend 1 month on Java practice core Java practice. You should be able to write inheritance, using the inheritance and using collections. You should be able to write at least 5 to 10 Java programs on your own. First, practice by copy pasting the code and understanding that, and later you try to write it on your own, at least 5 to 10 programs in core Java. Then you will obviously get that confidence you can crack this. And there are, see, I can say 70% of your work will be on data warehousing concepts like Hive, Pig, HBase, this stuff. Only 30% of your job will be using the, even lesser than that, using the coding part of it. Mapreduce. Especially when I talk about Mapreduce, it got reduced even to 5% in some cases. Okay, so mostly you'll see in almost all the projects, you will see HDFS and Hive, Pig, Impala, HBase only. Why I'm stressing on Mapreduce these concepts also is, in interviews, some guys will ask Mapreduce questions also, even though they are not writing anything in a Mapreduce. Okay, because they know it, they were there from so older days. They don't be experts in the upcoming tools, but they since they had an experience on these things, they ask that as well. Because you also put as experience as 3 years or 3.5 years or at least 2.5 years. They test you that whether you know Mapreduce also or not, because that was the only way that initial days of Hadoop was being programmed with. Okay, so nowadays anyway, like all these tools came up. Any more questions? Okay, thank you. Bye-bye.